Welcome to today's webcast on dynamic intersections with CTC Corridor Mapper. My name is Brian Lewandowski. I am the Civil Product Manager here at CTC Software, and I will be giving the presentation today. I want to start by talking about what corridor use is like in Civil 3D today. We start by building baselines and regions in our corridor from alignments profiles, as well as assemblies. We then start assigning targets through this interface that you've seen to control things like variability and width and slope and curb type. And we do this manually. We assign to one subassembly at a time. We go into here, we click where it says none, and we assign targets. And if you're like me, someone who's used corridors for many years, you know that this is quite time consuming, not to mention error prone. Corridors are certainly one of the most powerful tool sets in Civil 3D, but there's a lot of areas that are still pretty tricky and time consuming. And so what is Corridor Mapper? Those of you who don't know what it is, it's a complete replacement of the target assignment tool set in Civil 3D. And it looks like what you see here. And what we can do is we can link subassemblies, one or more subassemblies, to layers, to styles, to object names. And we can do so to multiple subassemblies at once. So I can grab a whole set of subassemblies like this, link them all to a particular layer or style, and then everything on that layer or with that style or with that object name will automatically get pulled in as a target. We can filter the layers or the styles we're using with a simple filter field right here. And when linking to layers, styles, and so forth doesn't work, there's still just good old-fashioned manual assignment. So like I said, we wanted to build a tool that would totally overhaul and replace and greatly improve what you guys are used to in target assignment in your corridors. And why are we focused on targeting? Because frankly, the rest of corridors are kind of easy, right? You make an alignment and profile, you build an assembly, and then you assign it to it, and then it just, extrudes that assembly along the length of the alignment and profile. All the detail, all the trickery in corridors, if you will, is in the targeting, and that's what Corridor Mapper's focuses. You can choose to include objects that exist in XREFs or not. There's even default settings here for as you add new subassemblies to your assemblies, some of the default behavior for those new subassemblies. Corridor Mapper allows you to mirror one subassembly to another. So for example, if I have a parent subassembly that has maybe some manual targets assigned, or maybe it's linked to a layer, I can set a whole host of other subassemblies to mirror that parent subassembly such that anything that happens to the parent subassembly, the mirrored or dependent subassemblies will assume the same targets. And this is really powerful because in a lot of our corridors, we have repeating scenarios from one region to the next. And every time we have a new region, we have a new subassembly instance that can get assigned its own targets. So I'll show you examples of all that stuff. So like I said, as that source subassembly changes, so do the mirrored subassemblies. We've simplified the surface targeting a bit. Again, we can grab multiple subassemblies at once like you can do natively for surface targeting, but it's a bit more intuitive. You can check multiple surfaces in here. In fact, for different subassemblies. And one feature we've added that's pretty nice is there's a default surface for new subassemblies. So as you build out your corridor, and new subassemblies need to be targeting the existing surface, you can set that default so you never even have to set those targets again. They just automatically get assigned. All right, I'm going to spend most of the time in Civil 3D like we normally do because I want to give you guys a feel of what this tool does. Now we're talking about some fairly detailed or involved corridor modeling here. So naturally, I can't start from square one. I'm not going to draw out alignments in front of you guys and profiles. I'm not going to draw out every single target object in front of you guys. I'm going to assemble the corridor so you get a feel for how Corridor Mapper fits into it and how it can greatly speed up and improve your guys' corridor modeling. So I've got a number of things created already here in the same way you guys would do. But then we're going to focus on how we build out this corridor. So what do we have here? Our example project here is a main through street with a couple crossing roads, a T intersection, as well as a four-way intersection in there. I've got centerline alignments and profiles. I've got offset alignments to represent things like the edge of the travelway, where the boulevard or the sidewalk starts. And I've also got a variety of polylines here where my driveways are going to be modeled. When it comes to the intersections, I've got some complexity here with turn lanes. And we're also leveraging connected alignments. So if you guys haven't used this, this is a really powerful tool that'll allow you to basically create a fillet alignment that's dynamic between two standard alignments. These can be centerline alignments or offset alignments. And so, for example, this alignment right here is a connected alignment that maintains a constant radius between my edge of travel way right here and my edge of travel way on this side road. These are real powerful. And in fact, the out-of-the-box intersection tool that comes with Civil 3D leverages this. Autodesk has exposed these to be able to be used independently. And that's a lot of what I'm going to be using today to model those curve returns. I've got a similar setup down here where we have connected alignments for the edge of travelway, that's the yellow, and then the dashed represents my the start of my sidewalk. So basically the width from here to here is where my curve and my boulevard will fit in. We also have ped ramp areas in those intersections. And then looking at my assemblies, what we have, we're going to model everything with two assemblies. I'm going to use one assembly for all of the through roads, be it the side roads or the main road. And it's going to handle the areas through the intersection, as well as areas away from the intersection. I'm leveraging a series of different conditional sub-assemblies, which we'll talk through. And then I also have a curve return sub-assembly that's going to manage the curve returns in both intersections. Now, as we go along here, I'm going to be highlighting Corridor Mapper and how that plugs in, of course, but I'm also going to give you guys a few tips and tricks that I've picked up and learned from you guys or just on the internet over the years and show you how that plugs into some of the latest corridor modeling workflows that I've come up with and am a fan of. So we're going to start by modeling the through roads, the main parts, and then we'll move into the intersections. But a lot of the approach and how we use Corridor Mapper will be similar, be it intersections or through road portions, okay? Now, I did talk in detail about all these sub-assemblies and my assemblies, but as we move along, I'll touch on those. Once again, if you have questions, feel free to type them into the GoToWebinar system. I'm jumping into this assuming people have some knowledge of corridors. So if something isn't quite clear to you, like I said, feel free to ask a question. All right, I'm going to start by creating a corridor. I'll leave it, we'll call it Main Street. And I'm going to use my main centerline alignment here. That's this one here, as well as the finished grade profile. And we'll start with this full road assembly down here. I'm not going to set a target surface, but I am going to set the start stationing and end stationing of my corridor. So what you're going to see me do throughout this webcast is basically build the standard corridor baseline or corridor region, and then leverage corridor mapper to do all the targeting for us. Okay, so native tools to simply just create our corridor. Okay, and then we'll use corridor mapper to manage all that targeting. I'm going to switch code set styles here as well. Okay, so if we zoom in here, my red lines are my curb lines. I've got sidewalk out here. And then as we start leveraging conditional sub-assemblies, we're going to have conditionals to put in driveways and drop curb. And we'll have conditionals in the intersection areas to manage ped ramps and associated sidewalks in that area. Now, ped ramp design is a very intricate thing, and there's a lot of different requirements around it. I could spend 5 hours on that, and I don't even know half the different ways you guys have to design this stuff. So I'm going to touch on some of it and leave some of it up to another time or another webcast. Okay, let's look at these intersections. How do we handle intersections? A standard way is you would build a different region in the area of your intersection where it drops curb on one side. And I've done that, and it's not a bad approach, but what I've found is it's more dynamic to use conditionals to have curb coming and going, and to use one assembly in one region through all of your intersections on your main road. And what I'm doing to support that is I'm going to use simple polylines I drew. Okay, they're kind of random here. The key point is where they start and where they end. That's basically where I want my curb to stop and start at these intersections. And all they do is they snap to the ends of the curb returns. Now, what does that look like? Let's jump into there, and we're going to use corridor mapper to do this. So I've got these polylines on some unique layers, intersection right, intersection left. Okay, we simply need to assign those targets to those subassemblies. So let's start fairly basic with corridor mapper. So this is the tool that's in the CIM Project Suite. It's right here. We'll launch corridor mapper. I'm going to pick this corridor. And here is corridor mapper if you guys haven't seen it before. This, by the way, is a tool that we had around for a couple of years. We did a total overhaul on it, and we released this new version just a couple months ago. So if you'd seen it before a while back, know that it's an entirely new tool now, a lot of new stuff to it. So here's how it works. At the top, we have our corridor. We can filter by baseline or region. We'll get more of those as we build this out further. We have surface targets, we have width targets, and we have slope and elevation targets. I'm going to start with width targets. Okay. And first thing we want to do is leverage this first pair of conditional subassemblies, and that is this one right here. So how does corridor mapper work? You simply highlight the subassembly or subassemblies. We can highlight multiple ones at once. Choose the one you want, and then link it to a layer, a style, or an object name. We'll use all of these different scenarios. To start with, I'm just going to link it to a particular layer. So I've got some naming here that keeps it handy for me. My intersection left subassembly, that's this one, and it's this one. So these are two subassemblies named the same, and they show up here. One of the other things we do that's unique to corridor mapper is when the assembly name, assembly group, and everything, the name itself is all the same, we group it together. And that's what this number column is. There's two subassemblies of this same name. So when you name them the same, they'll be grouped in corridor mapper, and we can assign the same targets at once to them. So I click on that layer, and it pulls in the target. And that's what shows up right here. Let's go to intersection right. I'll turn on that. That pulls in two targets. It's as simple as that. Let me click OK. And this is a very basic use of corridor mapper at this stage. And we can see our curve dropping off at those unique locations. All right, let's get some of the targets in for the rest of the through road, and then we'll jump into some of those intersections and these side roads. I've got a variety of targets out here. I've got yellow to represent my travel way, where I'm using offset alignments as well as widenings to manage that. Why do I use offset alignments? Because they can be data shortcutted, right? We can link these things into other drawings that might need that same geometry. I'm a big fan of that data being able to be linked between different drawings. Data shortcuts is one of the best ways to do that. Well, you could use a polyline. I'm a fan of using offset alignments in this way. We're also going to set targets for our boulevards. And then finally, we're going to use conditional sub-assemblies to differentiate between our driveways and our other curves. And this is pretty quick. And this is really one of the things I want to highlight with corridor mapper, is how quick it can be to assign targets. So I'm looking at our boulevards here. I can highlight all of these at once. See, we want to go to the style. I've got some offset alignments. With the boulevard style, we can assign 8 targets at once to all of those subassembly instances. We've got our lanes over here. This I'm going to link by layer. I'm going to grab a layer with those offset alignments. That's those yellow offset alignments right there. Okay. Now this is the approach to this. Linking things by layer or style, object name. Okay, now what you choose, whether you do it all layering or all styling, I think you're going to kind of focus towards one, but I'm going to show you use cases for all of them. We talked about the driveways themselves. That I've got simple polylines to be assigned to these conditionals. And again, conditionals, they work great in pairs. Those of you who might be new to conditional subassemblies, always use them in pairs. It gives you a very handy kind of if-else type scenario, whereas if you stack up 3 or more of them at once, you can get duplications in some areas. So I always use them in pairs in this way. This is really handy. One of my favorite things about corridor mapper is I highlight over here, I just start typing something, and it shows me layers based on that text. We want to do driveway left for the main road. 17 targets come in, okay? Now some of you might be thinking, well, Brian, I can link to layers in the native interface, right? And that's true, but it's not actually linking. You're just reading the layer one time to get those targets. And if anything changes, you have to go point to that layer again. You're not actually linking to it. So what we'll see in a moment here is, as target objects change, I simply refresh my corridor mapping, target mapping, and it'll pull in those new objects. Let's do the driveways right, like that. Okay. I'm going to hit OK to this. We see a lot of targets assigned at once. Okay. So do your alignment, your target geometry first, get your profile set up. Then when you move in your corridor, build a basic corridor and then use corridor mapper to assign these targets. Now, I talked about the dynamic link with these layers and styles, right? It's quite easy to illustrate. If I grab a few of these target objects, right? Let's say there were some other driveways I missed. Okay, these are just simple polylines. Okay, now that corridor mapping between the subassemblies and the layers is already there. So there's a secondary tool in corridor mapper that is called Automap Targets. If I run this and I pick my subassembly, it's going to read into those layers and styles we linked and then search the drawing if there's any new target objects that meet that criteria. And now that's what we find here. It tells me how many targets it's going to find. Hit yes to that, rebuilds my corridor, and now it models driveways in that area. And we can see that I've got a code set style that's putting some hatching in there. But if I grab my cross section, I'll also see that as well. Let's go to our section view over here. Grab our sample line and add that corridor into it. If you guys haven't done a lot of work on your code set styles, they are invaluable in terms of getting good views in your sections of your corridors, and as well as your assemblies. And by the way, if anyone wants the sample drawings that I'm using here with all the styles in them, contact us. We'll be happy to share them with you. Here's that cross section. We're seeing the drop curb and the driveway modeled, and then on this side, standard curb and sidewalk. Okay. So that's pretty straightforward, right? Those of you who've done a lot of corridor modeling, that's cool. I can do that, Brian, right? Let's move on. Here's where it gets more complicated, right? It's one thing to do just one road, but what about when we got side roads, and how do we model these intersections, and what is the best way to do that? And some of you might have a lot of different ways you've done that already, so hopefully I can give you a few new tips and tricks along the way, as well as show you how Corridor Mapper will really speed up some of that for you. Now, when it comes to the crossing alignments and profiles at intersections, there's another little trick I'd like to recommend here. Let's go and take a look at our crossing alignment and profile at this intersection. I've got alignment crossing here, a four-way intersection. What I use to link the profiles together is the native intersection tool. If I go and look at the profile, this is the north-south road here. You'll see I've got locks on here. These PVIs are locked to the cross slope of the through road. And so how do we do that? You use the intersection tool, not to model the entire intersection. We simply use the intersection tool. We choose a crossing location between two alignments. And if on the second screen you uncheck all of the options here to generate curb returns and offsets and all that kind of stuff, if you leave all of that off and you create an intersection, all it's going to do is create this single little marker here. But more importantly, what it's going to do, because you're specifying a primary and a secondary alignment, is it's going to make the secondary alignment, the profile, be linked to the primary profile. Now that's one way to keep them linked dynamically, such that if I change the primary profile, the secondary will move with it. Another option a lot of people do, it's not as dynamic, but it's handy, is you put a Kogel point right here, and you project that Kogel point to both profile views. You can then adjust, and by the way, that elevation of that Kogel point you set to the primary profile. You can then adjust your secondary profile to match into it. But I find use of this intersection tool for just linking profiles to be fairly handy. So I've done that not only at the center line, but also at the offset alignments. Okay. So when you create offset alignments from a center line alignment, you specify a distance that it offsets. You can also create a connected offset profile based on a slope. So I've assigned a 2% slope, so there's a linked profile inside this offset alignment as well. We're going to use that alignment and profile as a target to sync up our curb return regions with our through road regions. All right, let's move along here. Let's build out, I'm going to do it fairly quickly, the side roads, the through road portions of them, and then we'll focus on those intersections. But it's key, I wanted to show you guys how do I do it from start to beginning with Corridor Mapper. And while we're focused on intersections here, the key point I want to make is model your through roads first. So you start to get that area that you need to model with intersections first. And what defines those limits? It's those curb returns. That's the way I build this out. I let the start and end basically the PC and the PT of those curb returns dictate that. All right, we're going to go ahead and pick our corridor. If you guys don't use the contextual ribbon, it's another thing I recommend for adding baselines, adding regions. We're going to add 2nd Avenue. That's this center line over here. We'll give it the FG profile. Then with the corridor continually selected, we're going to select Add Regions. We'll add a region here. Now, where does this side road start? It starts at the outermost end of the curve. So this one is here. This curb return ends here. So we're going to go right to this one here. We're going to go all the way down to our construction limits. We'll say that's right there. And we'll use our full road assembly. Now, natively, this brings up the native target mapping window. But this is where we use corridor mapper. So at this stage, we just simply hit OK and we move on. Now, to really kind of show you the power, some of the power of corridor mapper, I'm going to build out these other baselines and regions as well, so I can show you how can we assign all those targets at once. So we're going to add baseline again. This one's going to be 3rd Ave. That's the center line over on this road. We're going to add a region. Again, we'll go right there up to our construction limits. Here's the full road. Hit OK to the manual target mapping. Got a region up there. Then we're going to add another region right down here. So it's on the same alignment. But it's going to be a separate region on this side of the road. Skipping the slow native target mapping window. Okay. We're going to map all these targets at once for all these regions. I'll go ahead and launch corridor mapper. And now what we'll see up here is we start to get filters. So I could work on just 2nd Ave if I want, and then my list of subassembly instances is trimmed down. Or if I go to no baseline filter, we see everything. Okay. And depending on how some of your stuff is named, you might need to do the filter. For example, we want to assign some driveway targets. I can't tell based on this because I'm using the same assembly for everything, which one is for which road. I can see targets assigned here. So I'm going to take advantage of the filter and go to 2nd Ave. And then I can see that, okay, my driveway left on here simply gets 2nd Ave. Driveway left over here. Driveway right. Driveway 2nd Ave right, okay? We'll go to the 3rd Ave, and we'll do the same thing there. In this case, though, we've got 2 instances, but of course, a pair for each one of them. So we can assign to 4 subassembly instances at once, the driveway left for 3rd Ave, and the driveway right for 3rd Ave. Okay. Some of the beauty of corridor mapper is just how kind of quick and transparent it is to hop between that stuff. You're not jumping into different interfaces. It's all in one form here. Now, some of the other stuff here, I'm going to pull my filter away, and let's start by looking at these boulevards. Those I want to assign all to boulevard secondary alignments. These are the offset alignments that represent the start of my sidewalk or the extent of my boulevard on my side roads. And I put those on a separate style. And the reason I turn the filter off up here for baselines is because I can see that I've got targets assigned up there where it says 2 for all of those. I can just grab all the other ones because all of those all should get the boulevard secondary set. Okay. Now think about that. You'd click into each one of these subassemblies each time to assign targets. We can do it all at once in this way. Similar thing with our lanes. I can see these two right here already have targets assigned. Those were the ones through the main, for the main street. So all of these are going to get assignments for the offset style secondary. Okay, that'll control the width of my drive lanes. And just like that, we'll hit OK. We should have the majority of our targets assigned for those regions. And then we get things like this, right? What happened? Where am I targeting? I'm seeing targets that it shouldn't. And in fact, I think I know what's going on here. I don't actually need to target. My standard width for this roadway is governed by my subassembly, so I'm going to pull away those targets for the lanes. We don't need to control the lane width by those offset subassemblies. So you can simply uncheck here. And one of the things you're going to run into is like you've got so many targets assigned, right? It's kind of what complex corridors turn into. You know, what do I have assigned here? Well, this number of targets right here is a link, and it opens up a secondary form where it shows you all of the targets you have assigned. And then right out here, we can of course see what is pulling those in, and that's the style right there. So I'm going to remove those, all of those, in fact. Okay. Yeah, someone asked again, can I get the sample, the drawing that I'm using here? Absolutely, I will share this drawing with you guys. Still missing one other thing. We'll rebuild our corridor, make sure our target's correct. This is the fun part of corridors, right? Let's jump back in there again and see what we're missing. So for Second Ave, and this is the other thing I like about Corridor Mapper is, again, the troubleshooting is quite easy. Let's check out our driveways left. Driveways Second Ave, that makes sense. Driveways right, that makes sense. Let's take a look at our lanes. Don't have any targets assigned there. I know what it is. We don't need the boulevard targets either. So a lot of times when you assign multiple targets like this, what you guys will find is it's going to shoot across the screen, right? And this is one of the things that is real smart about Corridor Mapper. It can read, you know, corridors in general, rather, it can read targets anywhere on the screen. But depending on how you're setting things up, you might get inadvertent targets, okay? So that's one of the things I want to drive home here. You guys have seen me referencing things by styles and layers, okay? The naming in corridors is still just as important. What do we name these subassemblies? That's important, right? What do we name the layers and the styles I'm assigning to objects? Okay, if we're going to leverage layers and styles and all this stuff to be linking to our subassemblies, it becomes important to keep track of that. And so I'd kind of stumbled into something there, and it becomes very easy to back out of it because that naming is important. And that's not something I can write a tool for to fix. That's just something you guys have to get kind of used to. That being said, there's a couple other supporting tools I'll mention here. You can automatically generate layers from subassemblies, so they're named the same as the subassemblies, or you can rename whole sets of subassemblies based on layers, or layers based on subassemblies. So they're pretty simple utilities, but they support this whole workflow here. All right, sorry about the confusion around the targeting there. Let's move on to these intersections a bit more, okay? And I'm not sure we're gonna have time to build out every corridor region here for these intersections, but it kind of repeats over and over. So I'm gonna start on this four-way one here because it's a bit more complex, so we can get a feel of what's happening here. Now, what's gonna be my baseline here? It's gonna be these connected alignments. As I said before, these are not manually drawn, these are basically connected alignments generated from these offset alignments, okay? So in a standard project, to me, you're always gonna have your center line alignments, you're gonna have your offset alignments, potentially multiple sets, and you're also gonna have connected alignments in those curve return areas. If you're not familiar with those tool sets, definitely get used to them. Real important to be building out target sets for your corridors. All right, what do I do first? It's just like the main roads. Build your standard baselines and regions, then use Corridor Mapper to do all the targeting for you. We'll start down here on the left and we'll build out 4 baselines and regions. And it's pretty straightforward. We're gonna take the 3rd Ave, Southwest. There's that connected profile that was automatically generated. I'll touch on that a bit in a profile view. Then we click the Add Regions button. We're gonna add one right here. I'm gonna go right from the endpoint there to the endpoint there. If you're not used to using that kind of interactive region building, highly recommend it. It's very fast, very powerful. And we're gonna hit OK to this native target mapping window. And I'm just gonna repeat that and build out 4 basic baselines and regions. These interactive, these contextual ribbon tools have been here for quite some time actually, but I still see a lot of folks jumping into corridor properties and kind of manually setting that stuff one at a time. That has its place. I'm a big fan of leveraging this contextual ribbon though to build out individual regions and baselines like this. There's a couple other handy things with it too. I'll show you those in a bit. So we're going to do this northeast one here, the connected profile. And we'll add a region. I remember when they came out with this stuff, I was like, oh, so easy now. Or not necessarily easier, but at least easier to keep track of, right? This last one is the northwest quadrant here. We'll add a region right here. This one's going to go, by the way, this adding a region doesn't matter if you start at high station or low station. You just put this fill area in there. That's great. Okay. First thing, a couple settings. We need some more detailed frequency on here. Contextual ribbon, again, use edit frequency, edit one of those regions. Let's dial this up to 5 on curves and tangents, okay? We'll get more detail in there. And then still staying in the contextual ribbon, leverage match parameters. This will match parameters between different regions. So I can push this frequency between this source region, click here and then click there, down here and here, and we can assign that frequency setting to all regions at once. One question came in about the connected alignments and profiles. Can you add a connected profile to a connected alignment after the alignment has been created? I don't think so. I was trying to do that the other day. In fact, you have to do it at the get-go, create that connected profile. So if anyone knows otherwise, feel free to type that in the chat window. But to my knowledge, I don't think you can do that. All right, let's start. We've got a number of things. We've got to get ped ramps in here. We've got to manage our sidewalk around here. We've got to match into the center line here with our drive lane, and we also have to tie into the edge of travelway alignment right here. And here I want to use something else. We've been linking by layers and styles. And while we can do manual selection, some of this stuff in intersections is what we built object naming for, because I've got center line alignments, I've got offset alignments, different things I want to target. And while I could put them all on one layer, that's not always desirable. So what we want to be able to target is this alignment, this offset alignment, this offset alignment, and then in this intersection, this center line alignment. Now, what's a property that's seldom used in our Civil 3D objects? It's the description field. What if we put a description field in here? I can leverage this in Corridor Mapper. So it's almost like a tag. Think of it as a tag. I can tag all these alignments with this phrase, and then I can go into Corridor Mapper and it'll automatically suck in all of those alignments that have that tag or that description field. By the way, that description field is also just the one that you'll see right here on the information tab. So we're going to use object referencing, object naming, and description referencing now inside Corridor Mapper. So I can link to this name field, or I can link to this. I'm choosing description because I want to maintain my naming to keep separation between different use cases. But the description field, how often do we use that? All right, let's go back in Corridor Mapper. And this one works a bit different than that layer and style linking. I'm going to go to no baseline filters because, in fact, what I've got is in my curb return assembly, this is the one we're using now. This is a subassembly I want to use to target those alignments. This thing is named curb return. So I can turn off all the filters and just filter my subassembly names by curb return. That's the name of that lane subassembly. I can highlight all of these. And now we're going to go to the object tab. So we haven't used this one yet. So when layer and style don't make sense, object name or description may play a role. So remember how I put in that phrase curb return. I can use asterisks in here, or I could just type it all out. And basically, anything with that description will show up. But if I just put asterisk in there, every valid target object is going to show up that has basically an empty description. Okay. You can use commas to reference different sets. There's all sorts of options you can do here. We're just going to reference the curb return ones. Now it works like this. It first pulls up the eligible objects so that you can see what it is you want to pull in as a target. If you click this, it commits that query, and you'll see those targets show up over here. If I click into the little total targets field, we'll see those are assigned here. Okay. And now when I hit OK to this, we'll see all of those unique different alignments and profiles assigned as targets to those different regions. Okay, so that's object referencing through naming or description of the objects. We've got a few other targets to work with here. Let's jump back into Corridor Mapper. We've got our ped ramp subassemblies. That's right here where we differentiate between a drop curb and a full curb for the ped ramp areas. I can grab all of those. And again, these are the conditional subassemblies, and they're named the same, and so that we see actually 2 instances of this one for a particular region. So there's 8 different subassembly instances. We'll grab here. This one we're going to go to layer because I've got some simple polylines drawn there that are going to trigger where the drop curve should go. And it pulls in 10 targets at once. Okay. Now we're going to go and filter by my Boulevard subassembly instances. Here we want the sidewalk to match these connected alignments. See how it's kind of off there? Okay, I've got connected alignments connecting the Boulevard offset on the main road with the side road here. And while we could again go to the filter for different baselines, we actually get some helpful information in here. The assembly name itself tells us which ones we want to work with. So that's for the full roads. We don't want to do that. We want the boulevards over here. And here we're going to use I think I've got that right. I think that's what I named, or the styles I gave to these connected alignments here, right? So we want that start of that sidewalk to match in right there. Hit OK to that. All right, things are coming together. So we've got that sidewalk following that connected alignment. I've put in my ped ramp pad here, that initial pad at least. And just a word about this, I mentioned this at the beginning. Some of you are saying that, well, Brian, I don't know that that is fully going to meet the bill there. There's a lot of different ways to do this. Depending on the requirements you have, if they're fairly stringent, I would still recommend you model at least your curb in the corridor, and then from there, use some feature line modeling. AutoGrader can help out great with that, automatically manipulating those feature lines. If you don't need to model this in detail on the surface, or you're fine just putting your polyline geometry to represent the layout of it, you know, so long as your surface is meeting that criteria, the ADA requirements, you're good there. So again, I could spend a ton of time on it, but there's just so many different kind of requirements on it. Probably doing in the future on it when I kind of gather maybe the top 5 different ways people have to design and model that stuff. But what I've done is modeled the sidewalk and then the ped ramp here, and then I just let it connect in between. Another strategy that I've recommended to people sometimes is to use an omitted link subassembly to model the sidewalk, and that would be to turn off this option here, set this to yes, omit the link, and target that out and have it model your sidewalk, but don't model anything in between. And then use feature lines to just model that ped ramp area in between. You can even use some feature line style hierarchy to control some of that so it links to the sidewalk and to the start of the ped ramp or the back of the curb. Okay, a lot of different things there we can use, just pointing out a few of those strategies. Now, all we've done so far are width and offset targets, right? But we've got profiles to assign as well. We've got to assign the profile of the center, or the center line alignments here, as well as the offset alignments here. And profile assignment is kind of weird, and so this is another area where I want to use that object description referencing. Because remember, let me explain this again. When I set up object targeting like this, object naming, and so forth, let's go to that quadrant right, here's where we did all this object description referencing, okay? This again is dynamic, just like the layers and styles. So as I go and tag any other alignment or profile with that description, it'll pull in a fifth and a sixth and a seventh target, okay? That's why I'm a fan of the object name and description as well. And so we've got some profile targets to set. And so again, I did some of this ahead of time just to save a little bit of time, but we need to target the side roads here. This is 3rd Avenue. If we take a look at that, take a look at my profile, all I've done in here, again, is in the description, is to throw a tag in there, okay? I've got that for the offset alignments, and so that we can follow that same approach. Now I go to the slope and elevation tab. I'm looking at my curve returns. Again, these are the lane portion right here. So we target center line and then my offset alignment. In this case, we want the profiles though. I'm going to use the same object referencing. And it finds all of those profiles. Now you could go out and you could manually pick those profiles in the drawing if you have them loaded in a profile view. You could reference them by name here. You could type in a whole bunch of unique names and pull them in. But use some dynamic tagging like this, and you can automatically pull in all these targets at once. And then we get all of these assigned to our corridor. Some of you might be thinking, what's happening behind the scenes here, Brian? What kind of targets are you creating? We're creating manual targets. Here's the native interface. We're manually assigning all of this stuff in the native way. I shouldn't say we're manually, we're automatically doing it, but in the native way, okay? Now, if you jump back and forth between these two, like you come in here and you start assigning some, and then you jump back to Quarter Mapper, Quarter Mapper is gonna bark at you and say, hey, I noticed there was some targets assigned through native methods. What do you wanna do with those? And you've got options on how to handle this. The workflow I'm recommending for you guys, and this is how we've built out the new Quarter Mapper, is that Quarter Mapper completely replaces this interface. Don't use that interface at all. I'm going to show you one other feature in Corridor Mapper, and that is both the manual selection option as well as the mirroring option. So we've got to tie into right-of-way, and what I've got here is a variety of feature lines that have just elevations pulled from existing ground. Okay, that's where we need to match into. And so we need to target those feature lines both for elevation as well as width with this back boulevard subassembly, as well as the back of driveway, the back of boulevard, and the through roads as well. So we've got a series of feature lines wrapping around the site here. Now these could be alignments with surface profiles, you name it. And so let me show you yet another way to leverage Quarter Mapper. I'm going to come into here. We're not going to turn any baseline filter on. I'm going to start with our width ones, and I want to filter my right of way. These are all my sub-assemblies with the text right of way in them. There's a whole bunch of them. All of these things basically need to target the same feature lines. Now we can manually go through and we can select the feature line that applies to a given area, right? But I like to create more dynamic target mappings. So what if we select all of these feature lines? I've got 5 of them here. For all of the right-of-way. You could join them or have them more separated, okay? And we're gonna manually assign those 5 targets to that first subassembly instance. We got dozens of them here. If I look into my total targets window, I'm gonna see I've got all of those manually assigned feature lines. Now, when they're manually assigned like that, you can delete them out of here one by one. when they're pulled in by reference, you've got to pull the layer reference or the style reference away from it to remove those targets, okay? Now, if all of these should get the same set of targets, I don't really want to have to go through, right? But perhaps layer and style or object reference doesn't make sense in this case. And so here's where this method column comes into play. We can have a parent subassembly that has a series of targets put together through any means necessary. Then we can take a whole series of other subassemblies and set their method, instead of reference, which is the layer, style, or object thing we were talking about, we can set it to mirror. When we set it to mirror, this whole side of the interface changes. We're going to have these subassemblies mirror a parent subassembly. And that would be this one right here. So the only thing you have over here now are a list of subassemblies. There's a filter, of course, over here. I type right away. The only subassembly that shows up is the only one available to be mirrored because we don't want to create circular references. So those are automatically pulled out of there. So those 5 targets that were manually assigned, I can assign those through mirroring. It's kind of like an XREF almost, by assigning that subassembly's targets to every other subassembly. Okay. So we're assigning those same 5 targets to all of them at once. Now, some of these things like, what if multiple targets are found? Do we go to the nearest? Do we go to the farthest? Those come into play here, and so we make sure it sees the nearest target, okay? But in this way, we can assign what ends up being hundreds and hundreds of targets at once. In fact, let me turn on this option in here where you can have it confirm the number of targets before assigning them. I'm going to turn that on, just so it highlights the number for us. As I've walked you guys through this, we've assigned 329 width and offset targets and 16 slope and elevation targets. You guys know how time consuming that can be. So I'm going to hit yes to this, and we'll see all of those feature lines get pulled in as targets to control the width. Just rebuilding the corridor. Now everything's tying into the right of way. Now that controlled the slope, or excuse me, the width. So we would just do the same thing for the slope, okay? And I'll do it. It's the same process here. This one here, we're going to assign those feature lines. One more over here. I'm going to set all of these to mirror. So if you guys are building corridors, whether it's road design or something else, where you've got repeating regions and they stop and start all the time, you're going to find this mirror method to become quite valuable for you. Looks like I missed a few of the targets, but you get the idea there. So rebuilding the corridor, okay. And if we recall, so far all I've done is kind of assemble the corridor and all the targets. If we recall, when I started and I had those driveways over here, right? And I duplicated some of those. Everything we built out in our target mapping is saved there. It's not a one-time thing. All of these different references. See all the targets that are listed here. Okay, that's what we've been assigning. Okay, and it can be daunting when you look at it like this, but break it down. Use the filtering right here. Use the baseline and region filtering up here. Use the layer and the style and the object filtering over here. And you'll be able to assign targets across the whole corridor at once, or just drill down to single areas if you choose. A few other things to point out: we can have it automatically exclude certain object types if we uncheck them here. We can have it include or exclude XREFs if we check that on or off here. There's an Automap function. I wasn't using this, but if you have a subassembly and a layer or a style that's named the same and you click Automap, it'll automatically check the layers on for you. So it'll even speed up the linking that you do in here. A lot of that depends on the setup ahead of time, the naming of your subassemblies, the layers, styles, and so forth, okay? So what you guys are gonna find as you start using this, if you haven't already, is that it'll change your workflow a little bit, but it's gonna speed it up a ton and it's gonna make changes to this happen way faster. I walked you guys through this and I assigned over 300 targets. If I didn't talk through it, in fact, you know, I prepare for my webcasts, I ran through and built this corridor up in about 5 minutes because of how fast I can assign these targets and how quickly they'll respond to changes that I make. So that is Corridor Mapper, what I wanted to show you guys today. If you're wondering how you get it, it's part of the CIM Project Suite. The CIM Project Suite is this whole set of tools up here. I highlighted one of them. We have them for pipe networks, for labeling, for QTO, for sheet creation, all sorts of different things. It's all part of that. If you don't have the CIM Project Suite, download a trial or contact your reseller. In the US, that's ATG. In Canada, that's SolidCAD. And if you're outside of that, just contact CTC software directly. The trials you can download right from CTC software. You can try out CIM Projects or CIM Project Suite, as well as Corridor Mapper, as well as many of the other tools that we have. Wish you guys all a wonderful day. Thanks again for hanging out, and we will see you next time.